Guten Tag. Was machst du denn?
Ich bin
wie viele zusammen?
C'est bon ça. Parce qu'en Angleterre, j'avais pas de brosse à dents. Bonne soirée. T'as ramené la brosse à dents, ta serviette aussi. Ouais, c'est bon, c'est tout là. Je crois que c'est mieux. Au revoir. Bon, allez.
Ciao, ciao.
Tu commences très bien. C'est pas moi. Je pense pas quand.
So, did you get that? That we want
One person.
we want to watch the film.
Yes, please.
a while it hardens, and this is one of the stable ones. You can see it doesn't crack. If it cracked, then we would get a tiny layer of air between, for instance, the surrounding ground and our borehole heat exchanger, or around our pipes. And if we have that tiny layer of air, then we have an insulator in our borehole heat exchanger. And we don't want that, because that makes it less efficient.
So, all these allowed for temperature control, yes. And now we can go and compare the total. There's a meter like this in the hot also, which put together it. And it's a little more than the sum of these two. That's because also something is happening on the way from the hole to the hot, because then it's like a horizontal plant, a horizontal system, because they are not isolated. Just plastic pipe got it one below.
J'ai ramené ma computer.
C'est demain matin, c'est vous qui allez bosser. Non, on ne sait pas comment on fait, nous. Une fois que on aura tout mis en place, on n'aurait plus qu'à donner.
Last year, in January, we visited the nuclear power plant of Chinon with our European partners. We only had access to the museum where the different stages of the process are presented.
We are going to describe how a nuclear power plant works.
There are three main parts: the reactor building, the generator with turbines, and the cooling towers.
The primary circuit contains the pressurized water which surrounds the fuel assemblies and extracts the heat produced by the nuclear reaction from them.
The secondary circuit is used to convert the energy. The pressurized water is at the temperature of over 300 degrees. When it comes into contact with the tubes, the secondary circuit water turns to steam. This steam drives the turbine generator, which generates electricity. The steam is then condensated and returned to the steam generator.
The cooling circuit. The steam is condensed using water in a third circuit, known as the cooling circuit. The steam which is used to drive the turbine cools and condenses when it comes into contact over tubes. The warm water is dispersed at the base of the tower and runs down through perforated plates. It is cooled at as a result of contact with the air draft rising.
Nuclear power produced a lot of energy with very little resource. There is no smoke or CO2 released, but there are radioactive waste. It is very, very dangerous. There are limited quantities of energy.
In the 70s, France wanted to be more independent with its energy sources, so they invested in nuclear power plants.
This kind of energy produced doesn't reject CO2. Even if we see a huge cloud of steam coming out of the cooling towers, 98% of electricity in our region is produced with uranium.
This map is edited by an anti-nuclear organization presenting the most important danger of the nuclear energy. We can see on this map the nuclear power plants. They are about 20. We have also many unmined uranium. Many stocks of roasted, and we can see the military using of nuclear energy. It's a printing, and it looks very dangerous.
Nuclear is a dangerous source of energy, first because of the extraction and the production of uranium. For example, transporting uranium or on African roads.
This is a real example of the dangers of nuclear power, the explosion of the Japanese Fukushima reactor.